Hello students, in this video we'll prove that the uniform limit of Riemann integrable functions is Riemann integrable. Let's suppose that Fn converges uniformly to a function f, and Fn is Riemann integrable for every n. Okay, then f is Riemann integrable and we have a limit result. What's our limit result? And the limit as n approaches infinity of the integral from a to b of Fn of x dx is equal to the integral from a to b of f of x dx. Okay, so now I have a limit interchange here because these integrals are themselves limits. So I have a limit of a limit, and over here I have a limit of the opposite limit. So I've changed the limits of I've changed the order of the limits. I've changed the order of two infinite limits, which is not always possible. So this is a very powerful result. So how do we prove this? We're going to let epsilon be greater than 0. And then pick n capital and n. Such that what? Such that Fn of x minus f of x is less than epsilon over 3 times the length of the interval if n is bigger than or equal to n capital. So this is for n bigger than or equal to n capital. Okay, I can certainly do this, and this is valid for all x in a, b. So this estimate over here is valid for all x in the interval a to b. Okay, cool. Now, what I'm going to do is this. So now pick a partition P. Of AB, such that the difference of the upper sum for that fixed n minus the lower sum for that fixed n is less than epsilon over 3. We can do this, of course, because the Fn are Riemann integrable. So I can actually find a partition such that this is true. And then now what can I do? So now let me estimate the difference of the upper sum of f minus Fn. So the upper sum of f minus Fn on this partition is going to be what? Well, I'm going to do the supremum over all of these expressions at every point in my partition, but the supremum of those points is controlled by what? For any point in that partition, I can say that the supremum is less than epsilon over 3b minus a. So in other words, this is going to be less than, the supremum is epsilon over 3b minus a, times the sum of the points, the sum of the xj plus 1 minus xj, so I pull the supremum out of the Riemann sum, and so this is just going to telescope to b minus a, so this is going to be actually just equal to epsilon over 3. Okay, so likewise we know what? So now for the lower sum, what can I do? I know that this thing over here, I know that Fn minus f of x is bigger than negative epsilon over 3b minus a, so similarly, what do we have? Similarly, we have that the lower sum of f minus Fn on that partition is bigger than negative epsilon over 3. Negative epsilon over 3, because I can make the infimum over here, the infimum is definitely smaller than negative epsilon over 3, okay? Times b minus a. So now I have those two estimates. Great. And so now we're going to estimate the difference of the upper and the lower sums of f and g. So if I have the upper sum of f on this partition minus the lower sum of f on this partition for that limit function, what can I say? I can make the upper sum bigger by adding, so if I add and subtract something to f, I can make it bigger, so I'm going to make the upper sum bigger by writing f as this plus this, because the supremum gets bigger if you add, the supremum of the sum is going to be less than or equal to the sum of the supremums. So so I can get bigger by doing that. Now the infimum of the sum is less than or equal to the sum of the infimum are less than the infimum of the sum. So now for this, I have the opposite inequality. So what we're going to do is minus what? We're going to have a minus L of what? L of f minus Fn p over here. And then a minus what? Minus L of f n p, okay? Now if we look at these two terms over here, so this term over here and this term over here, if I subtract those two terms, those give me an epsilon over 3. And then this is less than epsilon over 3, and that's less than epsilon over 3 with a negative negative, right? If I flip the signs over here, I can say that negative L f minus f n p is less than epsilon over 3, right? And so now all these things together are less than epsilon, right? So this thing over here is going to be cumulatively less than epsilon, and we've proven that f is Riemann integrable. So that proves that f is Riemann integrable. Great. All right, now how about this limit result? The rest is actually relatively straightforward, because what I can say is the following. So if I look, if n is bigger than or equal to n, then the integral from a to b of fn of x dx minus the integral from a to b of f of x dx is less than or equal to the absolute integral from a to b by the triangle inequality of fn of x minus f of x dx. And now for every x in this interval, I know this is less than epsilon over 3b minus a. So these things over here are less than epsilon over 3b minus a. So this is going to be less than epsilon over 3. So that says if n is bigger than or equal to n, these integrals get close to that limit. Therefore, we have this limit result, and we have the limit of the integral, the limit of the integrals of the fn is the integral of the limit of f. Thank you very much.